Now let's check out some of the names now that we had before. We can see that all of the positive ions, the name is the same name as the element, no difference. But once you get over to the negative side, we have that IDE at the end. You got to make sure you put that there. So we have not nitrogen, but nitride, phosphide, oxide, sulfide, etc. And you'll find these in your book. It should be on page 134. All right, so let's stop here and see if you can answer these questions, then come back and check your results. So how many electrons must be lost or gained by the following atoms to form ions, and then what charge would result? So we have barium, 2A, sulfur, 6A. And then the second question, what's the symbol and charge on the ions with the following electron and proton arrangement? 26 protons and 23 electrons, 35 protons and 36 electrons. So you might want to pause the video at this point and answer those questions, and then come back and check your results. Okay, and here are the results. Barium, group 2A, they lose 2 electrons and get a charge of +2, because now they have 2 more protons and electrons. Sulfur in group 6A gain 2 electrons, get a charge of -2, because now they have 2 more electrons than the protons. Question 2, the ion would be Fe, and we get that from looking up the 26 protons, that's the atomic number. And then the +3 is because the 26 protons would be +26, 23 electrons would be -23, and so we get +3 for a difference. And the next one would be Br- or bromide. 35 protons gives us the symbol Br. We have 1 more electron than the protons. It's going to give us a -1 charge. Okay. Now, ionic compounds in general have high melting and boiling points. They're all solids at room temperature. They contain ionic bonds. Here's an example, table salt. So they have very strong ionic bonds. In fact, all ionic compounds are solids at room temperature. There are not any ionic gases nor ionic liquids. And if we take a look at inside a crystal, this is how people picture these ionic solids as looking. We have alternating sodium and chloride ions, and such that they're alternating because of the charge. All we know from the formula, which is NaCl, is that there's 1 sodium to 1 chlorine or chloride, but we don't know how many are in the crystal. We can't tell that by just looking at it. So let's see how we get the formulas for some of the compounds. So we'll start off with sodium chloride. So here we have a sodium atom with its valence electron, and we have chlorine with its 7 valence electrons. Remember the octet theory now. So what's going to happen, the sodium loses its electron to the chlorine, and we wind up with 2 ions formed. A sodium ion with a +1 charge, a chloride ion with a -1 charge. Notice if we add the 2 charges together, we get 0. And that's how we wind up with the formulas for the compounds. So if all it takes is 1 ion of each to give you 0, then that's what we're going to show in the formula, and we get sodium chloride for an answer. We always write the positive one first and then the -1. Or you say the cation and the anion. Also, we wouldn't want to use more than the smallest number. So you wouldn't say, well, I can get 0 if I used 3 sodium and 3 chloride, so couldn't it have Na3Cl3? The answer would be no. These all have to be in the simplest whole number ratio. All right, so let's look at another one. What about for magnesium and chlorine? So here we have a magnesium atom with 2 valence electrons, and we have 2 chloride atoms, that is, with the 7 valence electrons. So we're going to have the ratio 1 to 2 here, because magnesium atoms must lose those 2 electrons. And chlorine atoms will only gain 1, so it's going to take 2 chlorine atoms to gain those 2 electrons. And so then we wind up with 1 ion, 1 ion, 2 chlorides. If you look down here, a 1 to 2 ratio, it has to be represented in the formula. So this 2 is called a subscript, and it multiplies directly to its left. So there's 1 magnesium and 2 chlorides. We're not writing in the subscript 1. You notice that it's not showing up in the name, though. This 2 is not in the name. Well, let's look at another one. What about sodium and sulfur? Now, you might want to pause the video and try this on your own, and then come back and check the answer. Okay, here we go. So it's going to take 2 sodiums to 1 sulfur, and that's because sodium atoms will only lose 1 electron, and sulfur is looking to gain 2. So the number of electrons lost and gained have to be equal. That's going to give us 2 sodium ions formed and 1 sulfide. Now our formula has to represent that. So in order to show the 2 sodium, we write Na just once, and then we put the subscript 2 next to it. Remember, the 2 multiplies to its left, not to its right. And notice again, the name does not have the 2 in it. It would be incorrect to say disodium sulfide. Here's the last one we'll look at before we try some quiz. What about lithium nitride? Now here we're already being given the ions themselves. So if you notice, look at the charges, +1 and -3. It doesn't matter that it's lithium and nitride. As long as the charges are +1 and -3, we're going to wind up with the same ratio. And here we go. 3 lithium ions would give us a +3, with 1 nitride ion would give us -3, and we wind up then with Li3n. Net charge is 0. All right, here are a couple of questions for you to answer. So answer these on a separate piece of paper, then come back and check your results. Well, these pairs of elements more likely form ionic compounds. And then the second one, what are the formulas for the compounds formed by the following ions? All right, here are the answers. Chlorine and bromine will not form an ionic compound because they're both nonmetals. We have to have a metal and a nonmetal. And so therefore potassium and sulfur will form an ionic compound. Now what about for the formulas? You notice we have aluminum and bromide here. That's going to be AlBr3. Now you have potassium and oxide. It's going to take 2 potassiums to the 1 oxide. Good. Now for the last one, Ga3, +3 and O-2, it's going to be Ga2O3. Now I want to show you that what we could have done on that, make it even easier. And this works out good. So if I have, I'm just going to use X and Y. If I have X, and let's say it's 3+, and I have a Y, other element, and that's 2- like we had in that example. If you notice the 2 and the 3, the 3 and the 2, the amount of the charge for the first one will become the subscript of the second one, and vice versa. Well, this works out pretty well. It's just that you have to remember to reduce those numbers if you can. And here we have some ionic compounds and their names. And again, you notice the name, it just says what the ions are that are in it. We don't say any subscripts in the name. Now there are some sort of, the transition metals can form ions of varying charges. And here we have some. We have chromium with, could be 2 or 3. Let me change this now. Chromium can be 2 and 3. Copper can be 1 or 2. Gold can be 1 or 3. Iron can be 2 or 3. Lead can be 2 or 4. Silver can be 2 or 4. So we have to have a way of distinguishing these ions when they're in compounds. You should find this on page 135 in the text. So this is how we can name. One system says we can use a Roman numeral to indicate the charge, so that when we write the name, we could say chromium 3 or chromium 2. Now we only use these Roman numerals when we write the name in words. We never put Roman numerals inside our formula. Now the old system uses the suffix OUS and IC to indicate which is the higher or the lower charge. IC always means the higher. OUS always means the lower. Now IC doesn't necessarily mean 3. It does for chromium, but you notice it wouldn't for lead. Lead being +4 and +2. So let's look at some other ones then. So copper could be copper 1 or 2, or cuprous and cupric. Gold, gold 1 or gold 3. Aurus or auric. Iron 2, iron 3, ferrous or ferric. Lead 2 or lead 4, plumbous, plumbic. And lastly, tin 2 or tin 4, stannous and stannic. Now here's a periodic table of these ions. So again, you get a better feel for where they're located. Now I want you to notice that there are some, in my arrow again, There are some transition metals that only form an ion of one charge, like the zinc and the silver and the cadmium. So you would not have a Roman numeral indicating the charge if you were to write the name for compound. So if you're writing the compound, the formula for, like, say, silver chloride, you see how it's +1 and -1? The formula would be just AgCl. But if you were writing in words, you write silver and then you write chloride. You wouldn't put in silver Roman numeral 1. So only the Roman numerals if you have charges that can be different for that element. And it's only for the positive ion. Okay. So here's one for you to try. What are the formulas for chromium 3 nitride and gold 3 bromide? So what we need to do is come up with the ions for both. So chromium 3 and chromium 2 and gold 3 you could get just by looking at the Roman numerals. Nitride and bromide, you might want to check your periodic table. So I'm going to start you off with this one. This is chromium 2 nitride, and this is what the ions would be. So why don't you try to come up with the formula on your own, and then we'll see if you got it right. Okay, here's the answer. We need 3 chromiums and 2 nitrides to give a total charge of 0, and then we get Cr3N2. And you notice you could have just taken the 2 and switch it, and 3 and switch it, come up with that as well. Next we have gold 3 bromide, so that's going to be Au+3 and Br-. So what will the formula be here? We need 1 gold and 3 bromide to give us a charge of 0, so the formula AuBr3. So you notice the names now. AuBr3 was saying gold 3 because there's also a gold 1 out there. Now what if you were given the names, and given the formulas that is, and asked to come up with the names? I just want to show you how to do this, even though I'm not going to ask you to do this on an exam. So let's say we have FeCl2 and FeCl3. Well, we're going to have to find the Roman numeral that goes with the iron. Now we know that Cl is -1, so we could figure that out pretty easily. We're going to do both at the same time so you can compare them. So we start off with our formulas. So what I'm doing is I'm going to replace the symbol Cl with its charge. So it says Cl is -1, and there are 2 of them. I'm going to put an X in for the iron. So we have X plus 2 times -1 is 0, X minus 2 is 0, X equals 2. So that means that there's a 2 on the iron for a charge. And we'll do the same thing over here, FeCl3. 3 times -1 gives us X minus 3 is 0, X is +3. So then this would be iron Roman numeral 2 chloride and iron Roman numeral 3 chloride. Now if you just said iron chloride, it would be wrong because there can be 2 different forms of it. Now why don't you try this one? What is the name of PbO? And O is -2 in the compound. So what's the charge on the Pb, and then what's the name? So the X minus 2 is 0, X is +2, and the name then would be lead Roman numeral 2 oxide. Polyatomic ions are a group of atoms that act as one unit and they have a charge. And here are some examples. We have ammonium has the formula NH4, that means 1 nitrogen atom bonded to 4 hydrogen atoms. And overall the charge is +1. This all acts like one unit. Over here we have hydroxide. It's composed of 1 oxygen and 2 hydrogen atoms bonded together. Overall a charge of -1. Here we have 2 that are very common, also very close in formula. NO3-, which is nitrate, NO2-, which is nitrite. Now the 8 and the ite indicate oxygen is present. 8 usually means the most, and ite means the lesser, and it's usually less by 1. We have carbonates and phosphates, again very common substances. CO3, charge of -2, PO4, charge of -3. Hydrogen carbonate, also called bicarbonate, like in baking soda. It contains 5 atoms, hydrogen, carbon, and 3 oxygen atoms, all acting as one unit, charge of -1. And here are some examples you might have at home, like Plaster molding. Plaster is CaSO4. That Ca is calcium, and SO4 is a polyatomic ion called sulfate. So that's calcium sulfate. And here we have a bottle of a liquid fertilizer, which is really water with different compounds dissolved in it. And that contains sodium, and this is NO3 or nitrate, so that's sodium nitrate. And we can see down here at the bottom what these things are pictured to look like. Now, if you go to page 138, you should see this chart. Do you have to memorize the chart? No, you don't. But you want to be able to refer back to it if you need it. So, and they have blocked off the ones that are most common. So we have, you notice, nitrate NO3, 8-nite, as I mentioned earlier. You want to go down the list and notice like we have carbonates I mentioned, and sulfate, phosphate. Here's one, cyanide, Cn minus. You get acetate, all the atoms in it, charge of -1. But what about writing formulas with these polyatomic ions? We're going to follow the same rule. We want to use the smallest number of each type of ion so the total charge adds up to 0. Here's the difference. If we need more than one polyatomic ion, we're going to have to put it in parentheses and the subscript outside. So my example would be combining ammonium and oxide ions. Now you notice the charges. The charges are +1 and -2. So we need a +2 to balance off the -2. So the formula, now we put parentheses around the NH4 because we're using 2 of them, and we put the 2 outside. Remember, again, positive then negative. And so the name is just going to be ammonium oxide. I didn't have the name written down here for you. The name is just the name of the ions. So again, we're not saying that subscript 2. Okay. Now, why don't we stop here and see if you can write the formulas for these 3. So write them on a piece of paper, and then we come back and check them. Okay, here are the answers. Sodium phosphate would need 3 sodiums and 1 phosphate, formula, Na3PO4. Magnesium nitrate is going to need 1 magnesium and 2 nitrates, Mg parentheses NO3 parentheses 2. So you notice that we needed parentheses around the nitrate because we have 2 of them, but there's no parentheses around the phosphate because there's only 1 of them being used. And the last one, you notice that we're going to switch these numbers, so the 3 will wind up down here, and the 2 is going to wind up down there, and so we wind up with Al2 parentheses SO4 parentheses 3. The name, you notice, does not mention the 2 and the 3. Now this is on page 137. You see a list of common compounds that have polyatomic ions in them, and you might recognize these, some of them anyway. Let's see the first one, barium sulfate. If you ever had a GI series in a hospital, this is what you're drinking. You drink about 1 or 2 liters of this stuff. Looks kind of chalky. I think they flavored it though. Calcium carbonate is an antacid like in Tums or Rolaids. Calcium phosphate. People that have a low calcium might have to take some of this. Calcium sulfite preservative. Sulfate plaster cast. Silver nitrate, topical anti-infective. Silver can act like poison sometimes, and nitrate again can oxidize things. Some antacids, and you can look at the rest of those. And that's it for the slideshow.